it working now? Yeah, all right, great. All right, first I'd like to thank Matosin for this great conference. I've had a great time so far, in the sauna yesterday especially. And it seems like I'm the first of the presenters to obey the presenters wear pink, but yeah, hopefully there will be some more later on. I will talk today about ClojureScript and React Native, how you finally can write native mobile apps in your favorite language. My name is Viktor Eriksson. I'm from Stockholm, and I've been working with ClojureScript for about 2.5 years. I'm currently working at Piloxa, where we're trying to help people that take medication every day by developing a connected pill box. And we're doing that with ClojureScript and React Native. In this presentation, I'll go through first how React Native itself works. Then I'll go through how ClojureScript and React Native integrates. And then the different development environments that are available for ClojureScript and React Native. Then I'll talk a little about testing, since that's not obvious. And then in the end, I will compare ClojureScript and React Native to classic native mobile development. So first, React Native. It's a library developed by Facebook that allows you to write native mobile apps using JavaScript. So how does it work? Well, you have native components in Android or iOS that are controlled by a JavaScript thread. And the development experience is very similar to developing React apps, much more so than normal native mobile development. And some of you might think, well, this sounds like something that we've heard about before, Cordova Ionic, not too good performance-wise. But it's different, because in Cordova, what you have is basically a web view with an HTML page that is rendered. And the difference is, in React Native, there's no HTML, and there's no DOM. You just have JavaScript that controls pure native components. In more detail, one abstraction that I found quite helpful is the sort of a server-client model, where you have a JavaScript core server, which actually is JavaScript core, and that it does all the business logic, and it does sort of a server-side rendering, determining which components should be rendered. And then this is serialized and sent to the native part of the app that takes this and renders the actual components. And then the native client has some input. You have Bluetooth events, notifications. You click on something. Those events are also serialized and sent back to the JavaScript server that processes it and sends some new updates if things are supposed to be updated. So you have this bridge, React Native bridge in between. Something that is quite interesting is that if you run this offline on your phone, then the server and the client are running on the phone naturally. And they're both using JavaScript core, actually. Even on Android, they're using JavaScript core. So they're packing it with React Native. But if you're developing, then the native client is on your cell phone or on the simulator, but the JavaScript server is actually Chrome. So, and the events are sent over the bridge via WebSockets. So that you can debug your JavaScript, what's happening in the JavaScript world. As I said, the development experience is very similar to web, and components are actually styled by a subset of CSS they have ported. Luckily enough, they brought the good parts of CSS, Flexbox, but unfortunately, it's not entirely cross-platform. For example, shadows in Android are not the same as shadows in iOS. So things sort of work the same, but not really. A great selling point for React Native is the interop system between React Native and Platform Native. You can, if you just want to start a little bit with React Native, you can incrementally change some part of your app to be React Native, and it can communicate with the classic native. So you don't have to start from scratch with React Native. And this also works in reverse, that you can have a native component, a graph or something, and then you can just add an interop layer, and then you can add that component in React. So you can call native components as you would a React component. That's quite sweet. And this is how React Native, the development experience, looks. This is JSX, Facebook's templating language, or what do you call it, for writing React. And you can see the basic, and if you have seen JSX before, For React, you notice that it's almost exactly the same. So, back to Clojure, that's why we're all here. So why is ClojureScript suited for React Native? Well, firstly, the JavaScript interop is trivial and very good, so it's very easy to just use current React Native libraries or other things just out of the box. And another thing that is very good is that web development with ClojureScript thus far has been focused around the React community, which means that available ClojureScript React wrappers such as OM, Regent, and RUM work more or less out of the box with React Native. Since the input React Native, or React Native relies heavily on React, there's not much of a difference. There's one downside though with using ClojureScript and React Native. With vanilla React Native, you get sub-second iterations, so when you save your code, in less than a second you will see the change on the emulator. But with ClojureScript, you have the ClojureScript compilation stage, so that sub-second is more like 4 or 5 seconds in my experience. And because you also have the ClojureScript, and then you have also the React Native packager that packages the JavaScript code and sends it to, starts this server and the WebSockets and sends the code to the native app. And the native packager is sort of Facebook's take on JavaScript bundlers, such as Webpack, but they didn't want to use Webpack because it was too slow. So it's faster, but it's also sort of hacky if you try to go into the internals. So, some code. Here on the left side you see vanilla React Native, and to the right you see ClojureScript. And in this example I will use Regent. And the first thing you do is you require React, or in ClojureScript that is handled by Regent. The second thing that differs from normal web is that you require components from React Native. And in ClojureScript you have to require React Native, and then you also have to use a Regent helper function that is called adapt React class that takes a React component and converts it to a Regent component. But then, when you get to writing the actual component, it's quite obvious which language is more beautiful, elegant, and better. So yeah, it's very good to write apps like this. The development environments for React Native and ClojureScript. As most of you know, Clojure has two competing build tools, Lightning and Boot, and both of them are represented in the React Native space. Boot React Native uses Boot, surprise, surprise. It works closer to the React Native packager, meaning that the output of React Native Boot is easier for the React Native packager to understand, meaning that it yields better runtime errors. It is a little slower though, and it's sort of not as polished out-of-the-box experience as Renatal, is my personal experience at least. The other alternative is Renatal. It uses Lightning. It has one major issue though, is that the code, the runtime errors, the way it works, it means that the runtime errors are not traceable back to the ClojureScript file that triggered error, which makes debugging quite difficult. So I eventually switched from Renatal to Boot React Native. But it has excellent templates for Reframe, Omnex, and RUM, so for your React Native projects. My experience from the community is that the most commonly used front-end framework is Reframe, that uses Regent as its React wrapper. Testing. Naturally, you want to test all your component or everything, especially since we're working with a medical app that everything needs to be safe. And you can actually test everything in Node.js by first you have to mock out, I'm going to say that there are sort of 3 parts of the testing. You want to test your business logic, the component rendering, and then like the integration tests, like firing up a simulator and triggering notifications, things like that. But the logic and the components can be tested in Node.js. But you first have to mock out React Native using a library called React Native Mock. And then you have to mock out all your JavaScript requires. And that's not the Clojure require, that's JS/require. For example, in React Native you require an image, or you require another React Native library. all those libraries must be mocked out, and you can use a library called mockery for that. And then, if you've done that, then your code will run in Node, and you can do all the tests. For example, in Reframe, you can test your subscriptions, etc. And then you actually can test your components, the rendering of your components. It might sound strange to do that in Node, and you're not using the classic server-side rendering, but you can use Enzyme's render function. I don't know how it works, but it does. So it'll render your component and make sure there are no JavaScript errors. And you can also test for the nodes that it child nodes and stuff. I haven't gotten to the part of the proper integration tests yet, but my experience is that most of the time, thus far, the errors occur in the JavaScript space. So, to compare, React Native and ClojureScript, what it has naturally, ClojureScript, that's like a big pro of using that. It's a wonderful language, you have lazy sequences, all these magic things. And the multi-platform is actually very, very good. I was able to transfer an app from iOS to Android in about 2 days, but probably most apps could be transferred in about a week, because most of the things just work. Like if you design it, the interface in iOS, it just looks sort of the same, but with an Android touch when you look at it on Android. Another very good thing about React Native and ClojureScript is there's a lot of smart people in the JavaScript and ClojureScript community that have thought hard about these powerful abstractions, such as Omnext, Reframe, DataScript. You have a lot of interesting stuff happening, and they're just available to you out of the box if you use React Native and ClojureScript. And even though the iteration in ClojureScript is not yet as fast as React Native vanilla, it's still, in my experience, a lot faster and a lot easier to develop a web app or a mobile app as a web app. Just like you just want to add a component, then I just add a new vector text, and I put some text in, and then add some styling, like some CSS styling. I think my experience is that development flow is really fast. On the other hand, the classic native with Java or Objective-C, you get better performance. My experience is that even though there's a lot of work in the React Native space on the performance side, it's still not comparable to the properly multi-threaded nature of real native. And naturally, the classic native have a much more mature community. Maybe something that people from Clojure are not too afraid that it doesn't exist, because Clojure is also a small language. But there's a lot more documentation, tutorials. Yeah, everything is expecting, almost everything. It's changing, but almost everything today is expecting a classic native approach. So yeah, the majority of the researchers expect that. And the other thing is that it has a much more mature API than the classic native. React Native is updated every second week with a new release, and there are still breaking changes. And it could be a good thing that things are developing fast, but it can also be a bad thing, depending on who you are or what situation you're in. So the recommendation, if you would start like a greenfield project today, my recommendation is, if you're comfortable with ClojureScript and you don't mind digging around in source code and GitHub and trying to like do things manually, then I think you should write as much as possible in React Native and ClojureScript, but go down to native for performance critical tasks, tasks that require hardware interaction, or things where really good libraries already exist that you can just write an interop layer for. But if not, then if you need performance, you should go with like classic native, Java or Objective-C, or if you need like the fast MVP development speed, then Code of Ionic is probably the better choice. But I'm a little too chicken to do some live coding, so I'm gonna like at least play you what how it can look if you I'm gonna show you how you get started with React Native, how it can look. So I'm gonna do this with boot React Native. So you open up that boot React Native, and you clone that repository. And I assume that most of you people know how to do that. And then you go into that directory, and they have an example project in the repo itself that you can go into. Let's see if I do that here. Yes. good. And this example project has the following structure, and there's a lot. It doesn't look exactly like this. I have some cursive specific stuff, but the important folders are app, where that's where the scaffolded React Native project lives, and SRC, as usual, is where your ClojureScript code lives. And then there's some other stuff, and there's the boot file, for example. And yeah, you can see the source. It's just a common it's ClojureScript as it looks normally. And the first thing we're going to do here is to start the ClojureScript compilation. And it's not just the ClojureScript compilation. Boot React Native does some other magic to make the ClojureScript code work well with React Native. But that's the first thing that I'm going to do. I'm going to start that. And when I was recording this, I was like, should I cut the movie so that it's faster? But I decided that no, it's probably better to show you that it's still a new technology and things are still not super fast, maybe. So yeah, as you see, like we have to patch the React Native packager, for example. There's a pull request, but it hasn't been accepted by Facebook yet. So there we compile the ClojureScript code, and then we're going into the React Native part. So as I said, let's see what like past me did here, but I think I should, I looked in the directory, and then I'm going into the app folder. So this is where the sort of the scaffolded React Native project lives. So this is, you have index, Android.js, index iOS. So this is how, when you scaffold your React Native project without ClojureScript, how it looks. So that's sort of separated there. And the first thing that you have to do is naturally to do an npm install. And like I'm going to say that in the Android folder is where all the Java code lives, the Java project. And in the iOS folder is where the Objective-C stuff lives. So you have two actual apps in there. Then I do the npm install. Luckily, I had already installed it before, so it's fast. And then I'm going to start the React Native packager. And what that's going to do is it's going to start a server, and it's going to do some other magic, and then bundle the JavaScript, and start a server that's listening, so that the native app then can connect to that. And the final thing I'm going to do, go back into the app folder, and then I'm going to use React Native's built-in terminal command, and I'm going to run iOS. And what it does for you is it locates your iOS project, it builds the iOS project, it launches the simulator, and it would have launched a packager if I hadn't already opened it. Let's see, here's the app. And this is, now it's loading. And this is also one of the things that I wanted to show you. It's not, like, it's definitely faster. If you compile it for production and you open your iOS app, it's going to be faster than this. But it still takes a while, and let's see what I do. And sometimes you have to reload it, because like the time it takes for the app to start, you have to reload the packager, and so it's a little quirky still. But let's see, I think it'll come around sooner or later. Yeah, that's why I recorded this in before. Yeah, all right, there's the app. And the last thing we're going to do is obviously write some code and update this. It has boot reload in it. So it's still, and this is the actual component. And if you're familiar with React, or like developing React in ClojureScript Regent, it's very similar. And that's some styling. And here's the hello world text component that I'm going to update to Tampere. And then I save that, and you can see it recompiling, and it updates. And then, yeah, exactly. And then I'm adding a new component here. And as I said, this is the thing, like you just add a new component, text, and you write something, and you save that when you're happy with it, and it just shows up. And it's very easy to design user interfaces in that way, is my experience. So that was it. Thank you very much. Any questions?
How would you compare React Native and ClojureScript to React Native in JavaScript?
Well, I don't know really how it doesn't give you that much to go back to JavaScript. Like as I said, the interoperability of ClojureScript serves for it's very good. The thing that I don't know if there are some things that the ClojureScript does, the compiler, the generated JavaScript code that could be less performant, possibly in React Native. I haven't investigated that, but in general, I haven't found a lot of urges to use JavaScript. ClojureScript works fine for me. Yeah, it's the only difference then is the compilation time, that it's faster. Other than that, I wouldn't say that there are many advantages of JavaScript over ClojureScript, in my opinion.
So one question I have is, so I haven't done any React Natives at all since like a year. And I was like, it seems like things haven't changed that much with React Native actually in a year. So you still have to build like your ClojureScript as one source, right?
No, what boot React Native does, it actually generates sort of it generates a node modules folder with all your ClojureScript output. So you actually, I haven't actually gotten the build one source file to work, because that was sort of, that thing was deprecated a couple of releases back, and I haven't got, it works, so no, you actually have all your, you don't have to build a single file. You can still work incrementally, like change the files.
Okay, so that's new. But then my impression is also that the React package manager, you're still sort of stuck with the way it works. I was hoping that would eventually become more pluggable, but that's not really happened, right?
Yeah, I don't think that's the priority. Like, it's like there are some issues open that, for example, an issue is with the Google require instead of the normal require. Like, if you could just plug in that and say like, oh, treat Google require as a normal require, but those things are not really picked up. So I don't think and I haven't got the impression that they're focusing on that at the moment. Like, in theory, it'd be pretty awesome to have ClojureScript to open up this server and like to not use the React Native packager at all. In theory, that could be possible. Haven't put in the time though.
Well, thanks for your talk. You said that you decided to switch from boot to renatal at some point of time. Why?
No, it was the reverse. I switched from renatal to boot.
Why?
Because of the runtime errors. Like, I couldn't trace the errors back to, so I was like working on something, and then it's like, oh, it doesn't work now. Where did I commit? And then I have like a lot of changes. So if you can't trace the calling ClojureScript function that created your error, it was hard. I don't like some people in the Clojure community don't like do errors, maybe, and then you maybe don't care too much about stack traces, but I do a lot of errors, so I'm happy when you can find the source of the error. Well, no more questions? Thank you very much then.